Hello viewers, in this video we're going to do A-level further maths, further pure 1, component 1, variant 1 from the May June 2025 series. We'll attempt question 4 in this video. You can check out the previous questions in the playlist. This video given some matrix and this rotation matrix where the data between 0 and 2 pi and two geometrical transformation in the Cartesian plane. State the type of each transformation and make clear the order of which they are applied. So it's going to be something like if you have M is the combined transformation matrix of two different transformation. This one you can very clearly see there's a rotation already because there's a trigonometric function there. And the other one here, you can see that the diagonal is 1, but the other, there's only number 2 in the other diagonal. On this bottom left there is a 0, so it's not a stretching or not an enlargement, but it's only maybe, or if I write it clearer like that, I just take this one and I transform it on the xy, you will just get row column, so x plus 2y, and row column is just y. So the x becomes x plus 2y, but the y remain the same. So if it's a 2D 2D, and I transform a point, so or maybe I transform 2 points so maybe it's a line. The y coordinate stays the same for both of the point. So the y coordinate stay the same, but the x coordinate it will move. So maybe it becomes like that, and then it also becomes, no, the y value is bigger on top, right? So the y value becomes further to the right, and then here is not so much, so it becomes like a slanted line. So this one we call as a shearing transformation. So okay, you have a rotation then and you have a shear, but how you make sure that is the order, which order they are applied. So if you want to do the matrix multiplication, you have to do it like that because of the order of the matrix. So the xy will become here, and then we have the x prime y prime. Okay, that's the transform or the coordinate after the transform. In matrix, they are not, what's the term for it? The multiplication, basically you cannot switch the place. You cannot switch like that. I think it's called commutative. It's non-commutative, right? The matrices. So you have to do this multiplication first before you do this one. So the rotation will come first. Okay, so because you are multiplying this rotational matrix first before you multiply the shearing matrix. Due to this non-commutative property, so we can just write it's a rotation and then shear. Okay, so that's the two type of transformation, and that's the order in which they are transformed. Okay, so 2 marks. So make sure the order and then also the two different transformation you are writing it correctly. Now part B, we want to find the value of data for which the transformation represented by M has a line of invariant points. Invariant is the opposite of variant, so means the point will be constant. So even though after you transform by this matrix M, so maybe if you have M multiplied by a coordinate, you get back the same coordinate. So that's the meaning of invariant. Even though you transform it, you still get back the same value or coordinate. So let's first do the matrix multiplication for M first. And I hope you guys can follow the matrix multiplication. You have the row multiplied by the column. So 1 cosine, 2 sine. Cosine, 2 sine. Next one, you also have 1 negative sine, then 2 cosine. So I have a 2 cosine minus sine. 0 cosine, 1 sine. And the last one is 0 negative sine and 1 cosine. End up, this one will be the final or the combined matrix of M, the transformation both combined together. Then we can go ahead also to write for invariant points. And we can take the M, we multiply it by coordinate xy arbitrary coordinate, and you get back the same arbitrary coordinates here. And yeah, we go ahead to multiply again. Okay, you have now is a dimensionally they are the same, and it's just a 2 by 1 matrix, or it's a vector, and we can go ahead and equate individually the component. So the x and the y, we can equate it. Now we have two equations with three unknown variable x, y, and theta. But since theta is in a trigonometric function, we can do some manipulation. We can still proceed to try and solve it. So we use this equation and isolate y first. And I think, yeah, we can solve or try and substitute into the first equation. So all I've done here is I put the y into the y here, this one. And we can go and expand and simplify. Okay, since x exists in each of the terms, right? Here got x, here got x, and then on the right hand side also have x. One of the solution is x equals to 0, but that doesn't give us any answer for theta. So we just cancel out both sides. We can ignore the case where x equals to 0. And yeah, we're going to simplify, get rid of this denominator over here also. After you get to this point, you can able to have this Pythagorean theorem here to kind of sort out this sine square plus cosine square, and everything else cancels nicely, so you have a cosine plus sine equals to 1. Okay, after simplification lah. So how to solve this one? I mean, you can square both sides and solve whatever, but if you can remember your basic trigo graph, let's start from 0. Okay, you have a sine graph looking like that. This is pi and 2 pi, right? Then cosine will be, yeah, like that. Maybe cosine I use red color. So cosine is red color, sine is black color. So when does these two sum to 1 is maybe what happened is at when 0 at the theta equals to 0, there is a cosine is 1, sine is 0. So this one is a solution actually. 0 is a solution, but it's not able to answer to this question because theta is greater than 0. So we go for the next one, which will be when it is at pi over 2 lah, right? This one is pi over 2, then sine will be at 1, cosine will be at 0. So this is included in our range for theta. So yes, we can use this one. This gives us theta will be pi over 2. And we don't need to worry about the other case. There will be -1, and yeah, the other case will be at 2 pi, which also we does not included in our range here. So this is the only answer for which this is true in the range. Okay, so yeah, this is question 4, I believe. Yep. Thanks for watching.